Last time on IB Biology.
Yeah. Today we are going back first to look at our experiment on osmosis. And we looked at this last time, and it was based on what you are remembered about osmosis from being in the 10th grade or before you came to this class. We put these onion cells into concentrations of 1 molar sucrose, 0.5 molar sucrose, and then into distilled water. And we observed what was happening. This picture here is coming from what one student took when they put the onion cells into a 1 molar solution. And here you can see that the area inside of the cell, which is the vacuole, and then the cell membrane, which is around the vacuole, that whole area of cell is moving inwards. Osmosis is happening in the onion cells. And water molecules are moving from one area to another area. The whole explanation behind osmosis requires an IB biology student to use terms like hypertonic, hypotonic, plasmolysis, osmotic gradient, selectively permeable membrane. So osmosis fits into this understanding, which is particles move across membranes by simple diffusion, facilitated diffusion, osmosis, and active transport. So we are going to look first at osmosis, and then we will take a quick look at simple diffusion.
And the yellow signifies the cell membrane, and the red signifies cell wall. And then blue signifies water molecules, and then these magnets signify sucrose. There's a concentration gradient where on the outside there are more sucrose molecules and ratio-wise, there's more sucrose molecules versus water molecules. While on the inside there are more water molecules versus sucrose molecules. So the whole point of osmosis is they want to kind of balance this ratio difference out so that they're pretty much equal. And because of this semi-permeable membrane, these sucral molecules on the outside can't get to the inside to equal the concentration gradient. So the water molecules on the inside have to pass through this semi-permeable membrane to the outside so that the ratio is equalized. And basically we say that on the outside the concentration is hypertonic, which means that it's more dense, it's more concentrated. And on the inside we say it's hypotonic. And because it's like pressure, they want to equalize. The water molecules inside will slowly kind of seep out. And once enough water molecules seep out to the outside, the cell will start shrinking through the process of plasmolysis.
Ordinarily, these solute molecules would also want to move because they can move around, they have energy. But they can't move and rearrange themselves and come to equilibrium. Why? Why can't they come to equilibrium? Because the membrane does not allow them to go through. So this is why the membrane is described as selectively permeable or semi-permeable. In this case of a living cell, it only allows water molecules to go in and out. So in other words, it's just a type of diffusion really, because diffusion, which is the other thing that we have to talk about, what is diffusion?
It's the movement of atoms and water molecules from a region of higher concentration to a region of lower concentration.
And I'm saying that this is a special type of diffusion because all diffusion is, like Hannah said, it's the spreading movement of a gas or liquid from an area of high concentration to an area of low concentration. If I had a beaker of aqueous ammonia, and I have this graduated cylinder here, and I have red litmus, I would want somebody to volunteer to design a simple demonstration to show how diffusion is happening.
I'll put this like up here, I
But
guess.
you got to show us what's happening to the right. Show us what's happening to the litmus. So what you have is simple diffusion. Ammonia is diffusing from this liquid state very quickly into the gas state. It's the spreading movement. And it's spread its way all the way up through here, and it's diffused, and it's made red litmus turn blue. Simple demonstration of simple diffusion. Diffusion happens in lots of parts of living organisms. Can anyone recall?
So when the living organism breathes in the air inside the lung diffuses into the blood system, to the cells.
So like in a leaf, like gases go in and out through the stomata in the leaves.
If this is a model of an onion cell, what do these strips represent? And what does the red line on the outside represent?
No, that's the cell membrane. Yeah, or the wall.
What's the red thing representing? The cell wall. We've got hypertonic, hypotonic. What's the meaning of this term though? Isotonic. They're at equilibrium. It's the same. So when the cell is isotonic with the outside, some people believe that nothing's moving at that point. Do you believe that, Chris? Things are still moving, isn't it?
Yeah, they're just exchanging at even rates.
They're now exchanging at an even rate. It's like one room in a museum gets filled up during the day with 50 people, and there are people outside in other rooms. But throughout the rest of the day, the cameras in that museum show always 50 people in the room. It's not going to be the same 50 people. So it's not going to be the same water molecules in here all day long. Some of them are going to go out, and others are going to be coming in. This rate of exchange would now be the same. And this cell is now in the same concentration as its surroundings. It's in equilibrium with its surroundings. This is what a living system seeks to have. This is what the cells of the human body need to have. Where our cells are bathed in a solution that is isotonic with the cells. When you want to transplant a kidney, that kidney must be put into a solution that is isotonic with the cells of the kidney. Cells lose water or they can gain water depending upon their surroundings. In a plant cell, like this onion cell, when the outside was very, very strong, had more solute and less water molecules, water went out. Until this creates a balance. The cell membrane is going to pull away from this cell wall, and when that happens, what is this called? Plasmolysis, right? So this diagram here, we have osmosis being the movement of water molecules from an area of their high concentration. An area of the high concentration of water molecules really means a dilute solution. And a dilute solution is described as hypotonic. It's a weak solution. Like a weak cup of tea, it's really hypotonic. Right? A lot of water in there and just a little bit of tea. But where you have a low concentration of water molecules in relation to solute, it's really a strong solution or a concentrated solution or a hypertonic solution. So osmosis, therefore, is really a special kind of diffusion, isn't it? It's a type of diffusion that's all about solvent and not about solute. Why can't it be about solute? Because the solute molecules are too big to pass through the membranes. So seeing that all molecules are in motion, the only ones that do exhibit this kind of diffusion are the solvents. And so therefore osmosis is really a special kind of diffusion that involves this selectively permeable or semi-permeable membrane. And in living systems, it's always going to involve water molecules as a solvent. So osmosis, therefore, is defined generally as the movement of water molecules from an area of a dilute solution, a hypotonic solution, or a high amount of water molecules to an area of a concentrated solution, a hypertonic solution, or a low amount of water molecules, passing through a selectively permeable membrane. Tony Cho asked me this question.
Oh God.
He asked me, how is it that this molecule is really going across the membrane? And he also wanted to know if these water molecules are really moving around at random. So we're going to move on to look at the structure of the water molecule. We're going to find out that water molecules are made up of hydrogen and oxygen. They're described as polar molecules. They have charges on them. So therefore, they're not really moving around completely at random, according to his question, which is valid because they're bound to be attracted to other things that are polar. When we're finished looking at the structure of the cell membrane, we'll find out that the cell membrane has polar parts and non-polar parts. So how is it that these water molecules get their way through here? That these molecules are small enough to wiggle their way through this membrane, this lipid bilayer. These are phospholipids. And there are also sections where there are tiny little openings where one water molecule can go through, and they go through single file, called aquaporins, where only water molecules can go through. So they're just big enough for one water molecule to go through at a time, single file. Osmotic or diffusion gradient. Maybe. Why is it referred to as a gradient though? A high to a low. So this is where the term gradient, it's an analogy. A gradient being a slope, What about the final vocabulary term on this list? Cytolysis. Put this in distilled water now, what's going to happen? This is a red blood cell, this is not a plant cell. Water goes into the red blood cell. The red blood cell is going to expand. It's going to keep expanding until what happens? Until it bursts. That is cytolysis. Why would cytolysis not be a problem with plant cells? This morning I put this sunflower into this graduated cylinder. This is distilled water in here. And the sunflower is loving it. It's been transpiring all day long. It's gone from 250 milliliters on this graduated cylinder to below 230. Right? 22 milliliters of water has gone up the xylem and gone out through the stomata and out into the atmosphere. The plant looks just as healthy. It even looks healthier than it was this morning. So this plant is not undergoing cytolysis. What's happening is that all these cells have taken in a lot of water, but they haven't burst. Why? But the cell wall is made of cellulose and it holds that pressure from the turgor or the taking in. It withstands that pressure and it makes the cell turgid. Right? So the cell wall is surrounding the cell membrane. And it's a freely permeable thing, but it's there to strengthen and it gives support. Plants don't have any skeleton made of bone or cartilage or chitin, but they support themselves with a special molecule that surrounds every cell. Cellulose. Look at this model here. On one side of the model, we have some sand and some mung bean seeds. A lot of mung bean seeds on one side. A lot of sand on the other side with a few mung bean seeds. And then both cups are separated by a piece of foil that has some holes in it. So there's some holes in this foil paper. These holes are just big enough to allow the sand to go through and not the seeds.
No, so like, it's representative of like osmosis because the sand is water, and then the beans are whatever's dissolved in the water. And when you shake it, it represents like the movement of the molecules like bumping into each other. And then because of that energy, they move through the semi-permeable membrane because they're small enough to fit through like the tiny little holes, but the beans aren't.
When I shake it like this, right, sand is moving over to this side. And in time, a lot of sand would start to get over on this side. Beans would, if I didn't have something in the middle, the beans would get over on this side too. But why aren't the beans going over? Because of the semi-permeable membrane. That's only big enough to allow what to go through?